where I understand it might get a little bit freaky. How do I officially solve this for x? I just got one more step. Add 3. Now this is where people would write 6 here, but it's not quite right, because this is what? What number is this? This is 2 different numbers. So officially you would write this like this. X equals 3 plus or minus 3. So what are my 2 answers? Now, you're not done yet. What are my 2 answers? One of them is going to be 3 plus 3, and the other one's going to be 3 minus 3. You just have to do each one separate, right? This is a nice way to write it quickly, but then you realize, oh, it's 2 separate numbers, 2 separate little things I've got to simplify. So I get x equals, x equals 0 or x equals 6. And if you think about it real quick, what do I square to get 9? 3 and negative 3. So x minus 3 has to be some kind of 3. There's got to be some kind of 3 here, and that's what this next step says. X minus 3 has to be some kind of 3. So you actually just got to think about it without using true algebra. You just got to think, well, what number would work? And that's exactly what the algebra puts here. Here, you guys try this one. What you got, Jeff? Sure. Let me catch up to you guys here. What's the first thing you did? Root. Plus or minus there, right? So these cancel each other, right? That's why we did a square root to kill that square. I always hate when the square somehow stays alive on the next step. It freaks everybody out. So 2y minus 5 equals plus or minus 9. So you could, right now, if you wanted to, you could write 2y minus 5 equals 9, or 2y minus 5 equals negative 9. And then and you could have done that here, too. I mean, right here. Right, whatever makes more sense. And then you just solve both of these. Add 5, that's 14, divided by 2, it's 7. Add 5, that's negative 4, divided by 2, you get negative 2. And of course, you can check your answers just like any equation. Throw them in there and make sure it actually works.
So, you write it down as 2 separate problems and
Yeah.
2 different ones.
Exactly. Because that's really what this symbol, the plus or minus symbol, means is there's actually 2 equations here. One of them is equal to positive 9, the other one's equal to negative 9. Now, you could also do this. Add 5. And then divide by 2, so you get this weird looking thing. And then you do 5 plus 9, 14 divided by 2 is 7, 5 minus 9, negative 4 divided by 2 is negative 2. You get the same answers again, of course. Okay, I'm trying to think about I want to show you so I can show you the quadratic.
So you move the 5 over and...
Yeah, so add the 5, and then divide by 2. That's how I got that expression there. So let's do one more of these together. Grab this. Sure. Equals. Yeah, I like it. Gross. So square root, plus or minus. What's the difference with this one is, that one I know the square root of A1. This one I don't know it, I don't want to know it. To be honest, I know it's a little bit more than 4. Ooh. So then I get 3x plus 11 equals plus or minus rad 17. To be honest, if you can't do this, that's actually nice. You don't have to actually simplify anything. Subtract 11, so I get 3x equals negative 11 plus or minus rad 17. And then, of course, I just have to divide by 3. Over there, I had to actually go further because I could simplify the rad. Here I can't, so I just leave it like that. If you've done any quadratic formula work, this should look familiar. It should look like an answer you would get from that. How many guys, anybody actually know the quadratic formula right now? Anybody know it but doesn't want to admit it? That's funny. That'd be awesome if I actually had somebody. Oh yeah, just don't want. Oh shit, I just admit it. So your last thing for today, and then I'll try to figure out. I'm just going to show it to you, see if you guys, if it looks familiar, and then tomorrow I'm going to try to show you a little bit about where it comes from, because it doesn't look like. So to be honest, what I'm going to try to do tomorrow is, if I start here, this is what the quadratic formula does. That's what everything looks like we've been working with, right? That's the most general form of all this factoring stuff we've been doing. So the quadratic formula says, let me solve that without putting numbers in. And that, of course, is every student's nightmare, is when the less numbers you got in the equation, the worse it looks. But not the harder it is, to be honest. So if you do solve this, you get negative b plus or minus square root of b squared by 4ac all over 2a.
My sister, my teacher made up a song.
Oh my God.
I was singing.
Not a fan.
We had a singer.
Too many
and I was
songs
like, oh.
in math. I like music, don't get me wrong. But this is just kind of cringy when you just sing it. No, just stop it. So I'm going to attempt to show you tomorrow, and if that scares you, you can just come tomorrow and do la la la. I don't want to see. I don't want to see. Because that's not obvious, is it? There's no way in hell that's obvious. But real quick for this one, yeah, you can't do that. We'll do some examples tomorrow, one way and another way, and show you to get the same answer. That's plenty for today.
No, I was listening.
You remember?
You just got to plug in though, right? Yeah.